Hello, this is our presentation on assembly line robots. I'm Carly Jaswin with Julian Kimball, Alex Hunton, and Kian Devuti.
So next we're gonna watch this quick video about why this invention is quite useful.
The Unimate created the definition of an industrial robot.
An industrial robot is something that has at least 3 degrees of freedom, which means 3 axes that can move independently. It has to be reprogrammable, and it has to be able to perform different tasks. And that's the universally agreed definition today.
The original Unimate had an awful lot of the major qualities that all industrial robots have today. It had to have a memory. It had to remember up to 100 different steps. There's 100 different things in a row it could do.
He has muscle, can pick up 75 pounds, and can stand extreme heat, cold, noxious odors, toxic gases, and radiation. He never complains, asks for a promotion, or demands a pay raise. He doesn't break, bend, or burn, and should make some other Unimate a perfect husband. Or maybe wife?
It was a primitive machine weighing 2,000 pounds, powered by hydraulics, with memory stored on a clunky magnetic drum. Its nervous system was operated by feedback or servo mechanisms, which measure where the robot is in space. When it reaches its pre-programmed point, it then performs its next maneuver. Another innovation was the end effector, the robot's hand. This is the part of the machine that interfaces with its surroundings. Each is designed to do a specific job, and it allowed robots to weld, drill, spray, and grip.
The end effector is another word for tooling. Now, the tooling can get pretty sophisticated because some of the tooling has sensors built into the clamp, let's say, that will allow it to exert just so much pressure on something.
However, aside from General Motors, buyers for the new robots were scarce.
If you don't understand something, and to try to get a normal businessman to understand a robot, you know, he thought you're talking about science fiction or something like that.
Management was skeptical, workers fearful. Corporate executives believed the robots wouldn't work. Employees feared they would work too well and replace them. But robots mostly did the jobs people didn't want to do. And in fact, robots created jobs. Humans had to design, build, operate, and repair them.
So they're able to use the kind of brain power that they have. Like one of the people that went to one of our classes learning how to program robots came out of it and said, gee, now I can finally use my brains for this company I've been working for 20 years instead of just my muscles.
By the mid-60s, even labor unions endorsed robots, recognizing the inevitable increase in productivity. But the original Unimate, with an $18,000 price tag, remained a tough sell.
What we did to get people started, we would rent the robot. You'd hire it, like a person. And we would say, at that time I said it's so many $6 an hour, I think, for the first shift, and $3 an hour for the second shift. So your labor gets cheaper.
The robot had one thing advantage immediately, and that is the robot can work 3 shifts or work 24 hours a day.
George and Joe set out to change public perception of the new machines. So they took their robotic show on the road.
Would you welcome Joe Engelberger? Joe?
And ultimately, the show that was so important to us was the Johnny Carson show. And that's where the idea was, suppose we try to give the impression that the robot could do the whole show. So you had the 3 scenes. 1, it could play better golf than Carson could.
Is that wild?
2, it could do the beer commercial better than anybody.
You see, in case you get tired and can't make it to the show someday, we can program the machine to do a commercial.
And 3, it could lead the orchestra.
Now, what he's doing now is to program what he's going to have the machine do. He's putting this information into the machine.
And that gave me a chance to show how the arm moved with a baton.
Take it on the downbeat.
The public loved the Unimate, but industrial orders did not pour in. It took Unimation 14 years to make a profit. But there was another market that saw the potential of robotics: the Japanese. Theirs was a nation in need of a labor force, and they immediately embraced the potential of robots.
The Japanese outclassed us in quality and cost and manufacturing and features, and that's where the difference is made. If I talk to an American executive, they want to know how fast they're getting their money back. The Japanese would look long range.
Kawasaki and Unimation formed a joint venture. The Japanese quickly took the lead in the robotics industry. While in the early 1970s, several Stanford graduates recognized the potential of these breakthroughs for private industry and formed a company to manufacture and market these intelligent robot arms.
First, we're going to start off with a brief introduction to assembly line robots. So we're going to talk about the broad category, which is assembly line robots. So assembly line robots are essentially factory robots made to boost manufacturing speed and streamline industrial processes. So what I'm going to do in this slide is basically unpack that first sentence. And so the key word is factory robot. So you're not going to find an assembly line robot doing anything other for the most of it. You're not going to see it do anything other than actual factory work. And so boosting manufacturing speed, this means that it increases the rate of production. They put parts and products together with more speed and accuracy than a human. So they basically build things that humans would normally build, but it's also menial tasks because the assembly line robot runs off of a program. And because of that, it's easily configurable, but it's not an AI like a human. It can't learn new things. So it's just something to build things that have already been made.
So for my slide, I'm talking about the research and design of assembly robots. And being as there are multiple different variations of assembly robots throughout the years, especially now, everything from different tasks have been specialized for different robots. I'm just going to take apart one of the most famous and most early robots, the Unimate, which we covered later in other slides as well. But this really gives a good idea of like the capability in the early development of assembly robots. So Unimate was the idea of George Duvall, who worked with Joseph Engelberg, developed the Unimate. They developed as a replacement for welding work that produces toxic fumes. So the idea came from the fact that like a lot of different jobs are either really repetitive, meaning you can do it like kind of quickly, you don't need some guy doing it all the time, you can have a robot, but you can also, they're dangerous, right? You're causing a lot of injuries. From a company perspective, right, that's a lot of money going down the drain, paying health bills or anything that the government says you got to pay because you hurt your worker. So now with this thing, they're able to just buy a robot and have it function as that. And that was the inception. That's the idea of it. And then they researched this further, and they made it. So it's an industry grade robot. It's considered highly reliable and easy to use. It's fully programmable. Fully programmable axes of motion, could handle parts weighing up to 500 pounds, and a dedicated electronic control is easy to learn and pick up. So it made it very easy to use. And its design, so moving on to the next slide, its design, thinking about it from what it was made to do, is really kind of be an almost universal thing. That was the main thing that they really wanted to hit with this one. It was more like a turret. It had 6 degrees of motion. It could go basically anywhere. It had a 7 feet extendable arm. It was highly precise to the millimeter because it had to do these very highly precise movements accurately and consistently, and that's why it was so successful, and why this invention really took off through this design, right? If you had this design, you're able to successfully solve the problem and really be successful in your industry.
Um, so onto the modern real world applications of these assembly line robots. Some applications for them include automotive components like pumps, motors, and gearboxes, as well as stuff like computers and consumer electronics. Um, Assembly line robots are very efficient because not only can they put together parts that are too small or intricate for a human, but they work very quickly and with great accuracy without tiring out or making mistakes. So, like Julian said, they're perfect for the more menial tasks where you don't need a brain to think about it. They're also good in applications where cleanliness is paramount, like pharmaceuticals and medical device assembly. Um, and they also aren't prone to debilitating injuries like carpal tunnel syndrome that come with repetitive work.
So it's pretty widely known that Henry Ford was the first person to kind of implement assembly lines into production, but he did so without using robots that could do their own thing. So Ford did use various machines, and they actually aided humans a lot more than than humans could previously work. So they still helped humans a lot. But they were still limited by the efficiency of a human and the speed at which they could do their job. And the machines couldn't really do their job on their own. They were kind of depending on the human to operate them. But Ford's invention was in 1913. The assembly line was first invented in 1913, and around 50 years later, in 1961, the first fully autonomous robot was brought into production, which was Unimate. It was the first assembly line robot, and it's a big landmark because it marks the first time that a robot has become a part of an assembly line. So before with Ford, there wasn't really any robots that would do their own job, but now with Unimate, robots were taking tasks from humans to increase production. They were first implemented by General Motors in 1961, and GM used them to again take some tasks off of human hands. And the invention was patented in 1954. Also, Unimate it increased efficiency, but it also took a lot of dangerous jobs away from workers like welding, so a lot of factory injuries went down as a result of having robots in the assembly lines.
So now we can go over to some other important information and also like really fun facts. So a lot of the misconceptions about assembly line robots is that they're going to completely replace humans. And so the fear behind it replacing humans is that a lot of people are going to be out of work. But then what they don't realize is that assembly line robots, implementing those robots, creates tons of new jobs. And I'll list a few. Firstly, humans have to program this robot to do the individual tasks, which means that after each task, if you want to do a different task or another task, or you want the assembly line robot to build something different, you're going to have to write a new program. And so you're going to have to hire programmers. Also, these assembly line robots are going to need maintenance. You're going to have maintenance workers. They run on electrical motors. You're going to have electricians. So basically what I'm trying to say is that you're replacing this one human worker with an assembly line robot that's going to take multiple workers to program and do this all. However, while it is going to have more people involved in this task, there's going to be less time allotted to the actual manufacturing of the product, and thus saving the time and also helping the economy by making products cheaper for consumers. In addition, fun fact, assembly line robots, there's miniature ones and they can operate on things smaller than a fly. And so examples of this are computer microprocessors or clock gears. And so this basically shows how accurate and precise the machines really are because they can operate on such a small scale. So thank you guys for listening and watching. I hope you guys really enjoyed assembly line robots and how they're revolutionizing our industries.
Just another note at the end of our presentation, we included a list of all of the citations we used. And if you want to check any of those out and get more information on these, I know it's really interesting. And thank you all for listening.